Filtration is a technique that uses the physical properties of solubility and particle size. For example, a solid that does not dissolve in a liquid. We can pour that mixture through a funnel with filter paper, allowing the water to flow through, holding the solid back. Another example is maybe having larger particles that you have in a mixture of sand. You can pour that sand mixture on a sieve where the sand particles are small enough to fall through, but the larger particles you want to filter out are not, separating the larger particles from the sand. Evaporation is a technique that can use melting point, boiling points, and solubility to help separate mixtures. For example, with salt water. Salt being completely dissolved in water, we cannot use a filter in order to separate that because the salt particles are small enough and dissolved in the water where it will simply flow through the filter along with the water. So we can separate this mixture by using the difference in melting and boiling points. Salt melts at over 800 degrees Celsius, where water boils at only 100 degrees Celsius. So if we heat this mixture up, the water will boil away from the salt long before the salt even begins to melt, effectively separating water and leaving the salt behind. Distillation is better used when we're separating a mixture of liquids, for example, ethanol dissolved in water, and it uses the difference in boiling points. For example, ethanol's boiling point is about 78 degrees, where water's boiling point is 100 degrees. So if we boil a mixture of ethanol and water, ethanol would change into a gas before water because it has a lower boiling point. Once those gas particles hits the surface of those glass tubes, it condenses back into a liquid, separating the two. Now, the key is to ensure that you remove the heat before you hit the boiling point of water so that you could keep the ethanol separated from water. Magnetism uses the magnetic properties of a substance to help us separate it. For example, having metals such as iron shillings and sand can be used by running a magnet over it and it will pull the iron out, leaving the sand behind. Now let's practice by pausing the video and thinking of ways that you can separate each of these mixtures based on what we just learned with our separation techniques and what we remember from physical properties of matter. The first is sugar completely dissolved in water. The second is rubbing alcohol dissolved in water, where the two have different boiling points. And the third one is a mixture of sand, iron, salt, and water dissolved together. And keep in mind that while salt will completely dissolve in water, sand and iron will not. The first one, sugar water. If we had sugar completely dissolved in water, then we would use evaporation because the boiling point of water is lower than the melting point of sucrose or sugar, and that allows us to boil water away from the sugar, leaving the sugar behind. Water and rubbing alcohol, two liquids dissolved in each other, so therefore we will use distillation because rubbing alcohol has a different boiling point than water, and we can boil off rubbing alcohol, leaving water behind. Now, this next mixture of sand, iron, salt, and water all dissolved together is a little tricky. Water and salt will completely dissolve. Sand will not completely dissolve in water, nor will iron. So our first step would be filtration, where we separate the salt water mixture from the sand iron mixture. Next, we will allow that sand iron mixture to dry and then use magnetism to separate the iron from the sand. Then we will go back to our salt water mixture and use evaporation to separate the water from the salt.